Hello, and welcome to Amazing Aircraft, the channel where we explore history's most incredible flying machines. Today, we will talk about the Lockheed U-2. This legendary spy plane flew higher than any other aircraft at the time and played a crucial role in the Cold War. The U-2 was a secret project that started in the 1950s when the US needed a way to spy on the Soviet Union and its allies without being detected or shot down by their air defenses. The U-2 was designed by Kelly Johnson, a genius engineer at Lockheed Skunk Works. This special division created some of the most advanced and innovative aircraft ever. The U-2 was unlike any other plane before it. It had a jet engine and a very long and thin wing, like a glider, that allowed it to fly at altitudes of over 70,000 feet, or 21 kilometers. That's almost twice as high as a commercial airliner and close to the edge of space. The U-2 could also carry a variety of cameras and sensors that could take high-resolution pictures and collect valuable intelligence from far above the ground. The U-2 was so unique and impressive that it earned the nickname Dragon Lady. It's still in service today after more than 60 years of flying. But how did the U-2 come to be? What were its missions and achievements? And what were the challenges and dangers of flying such a remarkable aircraft? Stay tuned as we reveal the fascinating story of the U-2 in this video. So buckle up and get ready for a high-altitude adventure with the U-2. The story of the U-2 began in the early 1950s when the U.S. military was looking for a better way to spy on the Soviet Union. After World War II, the U.S. was worried about the Soviet nuclear and missile programs, wanted to know more about their capabilities and intentions. However, the existing reconnaissance aircraft, such as the B-47 and B-57 bombers, were too slow, low, and vulnerable to Soviet air defenses. They could not fly over Soviet territory without risking being shot down or starting a war. The U.S. Air Force asked several aircraft companies to design a new plane that could fly at 70,000 feet, well above the reach of Soviet fighters and missiles, and take high-resolution photographs of Soviet targets. But most of these designs needed to be lighter, more complex, and more expensive. The Air Force rejected them all, but there was one company that had a different idea. Lockheed had a secret division called the Skunk Works, led by a brilliant engineer named Kelly Johnson. Johnson had designed some of the most famous planes in history, such as the P-38 Lightning and the P-80 Shooting Star. He was also known for completing projects ahead of schedule and under budget. Johnson devised a simple and elegant design for a spy plane. He took the fuselage of an F-104 fighter jet and attached long, slender wings to it. He removed the landing gear and the weapons and installed a powerful jet engine and a high-resolution camera. He called his design the CL-282. The CL-282 was unlike any other plane. It was essentially a jet-powered glider. It was very light, swift, and very high. Flying. It could reach an altitude of 73,000 feet and fly for 1,600 miles. It had a tiny radar cross-section, making it hard to detect, and it had only one pilot, who wore a special spacesuit to survive at such high altitudes. But there was one problem. The Air Force did not like it. They thought it was too risky and too unconventional. They did not want a plane with no landing gear or guns. They did not trust the engine or the camera. They preferred more conventional designs with multiple machines and more payload, so they rejected Johnson's design in favor of another plane, the Bell X-16. But Johnson did not give up. He knew his plane was better than anything else. He decided to show his design to another customer, the CIA. The CIA was interested in Johnson's design because they needed better intelligence on the Soviet Union. They had their project for aerial surveillance, codenamed Aquadone. They liked Johnson's plan because it was simple, cheap, and effective. They agreed to fund it secretly under their budget, so Johnson got his contract in March 1955 for 20 planes. He called them U-2s for utility and 2 for the second model. He built them in his secret factory in Burbank, California. With his team of engineers and mechanics, he faced many challenges and problems along the way. He had to find a special fuel that would not evaporate at high altitudes. He had to develop a new camera that could take sharp pictures from 70,000 feet. He had to design a space suit for the pilots. He had to find a place to test and fly his planes without being noticed. He solved all these problems with his creativity and ingenuity. He used a new type of fuel called JP7. He worked with James Baker and Richard Perkin to create a fantastic camera with a 1/8-inch lens. He collaborated with David Clark Company to make a custom spacesuit. he found an isolated airfield in Nevada called Groom Lake where he could test his planes in secrecy. He delivered his first plane by July 1955, just 4 months after getting the contract. He had all 20 planes by November 1956, ahead of schedule and under budget. He also trained his first pilots to fly his planes. They were Air Force officers who resigned their commissions and joined the CIA as civilians. They had to learn to pass the U-2, which was very different from any other plane. They had to pass very close to the stall speed, the minimum rate required to keep the plane in the air. They had to avoid sudden movements or turbulence, which could cause the plane to lose control. They had to land the plane on its belly, without wheels. On a runway, they had to wear a spacesuit and breathe pure oxygen for an hour before takeoff to prevent decompression sickness. They also had to be brave and skilled because they would fly over some of the most dangerous places in the world. The first test flight of the U-2 took place at Groom Lake on August 1, 1955. It was supposed to be just a high-speed taxi test, but the plane lifted off the ground at 70 knots, surprising the pilot, Tony Levier. He flew the aircraft for a few minutes and then tried to land it, but he found it hard to judge the distance to the ground because the plane had no wheels or flaps. He bounced the plane once before it stopped rolling but suffered only minor damage. The first intentional test flight occurred 3 days later, on August 4. Levier flew the plane for 40 minutes and reached an altitude of 32,000 feet. He found that the aircraft handled well at high altitudes, but it took a lot of work to land at low altitudes. He tried 6 times before he managed to land the plane safely. He discovered that the best way to land the plane was to touch down on the rear wheel first and then let it slide on its belly until it stopped. He also discovered that the aircraft had a lot of lift from its wings, which made it float over the runway for long distances. He needed a chase car driven by another pilot to tell him how high he was above the ground. He also discovered that flying the U-2 was a lot of fun. He said, "It was a beautiful airplane to fly. It was so smooth and quiet. I loved it." He trained other pilots to fly the U-2, who also loved it. They said, "It was like flying a magic carpet. It was like being in space. It was like being a spy." They were ready for their first mission, but where would they go? And what would they see? The primary purpose of the U-2 was to gather intelligence on the Soviet Union's nuclear and missile programs, which were a source of great concern for the United States during the Cold War. President Eisenhower approved overflights of Soviet territory in 1956 after being assured by the CIA that the U-2 was virtually undetectable by Soviet radar and that the pilot would not survive in case of a crash. The CIA selected and trained pilots who resigned from their military commissions and joined the agency as civilians. They flew from secret bases in Europe, Asia, and the Middle East, using cover stories and fake identities. The U-2 missions revealed important information about Soviet activities that surprised and relieved the American government. For example, one of the first overflights in July 1956 discovered the Baikonur Cosmodrome near Churatam, a giant rocket launch site unknown to the West. Another overflight in August 1957 photographed Moscow for the first time, showing that anti-aircraft guns or missiles did not heavily defend the city. A third overflight in September 1959 detected a new missile test site at Serishigan, where the Soviets were developing an anti-ballistic missile system. The most significant discovery made by the U-2 was that there was no bomber gap or missile gap between the US and the Soviet Union. The U-2 photographs showed that the Soviets had far fewer bombers and missiles than they claimed or than the Americans feared. This helped Eisenhower resist pressure from politicians and military leaders to increase defense spending and adopt a more aggressive posture toward the Soviet Union. However, the U-2 flights were less invisible than the CIA hoped. The Soviets detected and tracked the U-2 incursions into their airspace from the beginning. Using their advanced radar systems and interceptors, they protested vehemently to the US, accusing it of violating their sovereignty and threatening peace. They also tried to shoot down the U-2s with their fighters and missiles, but they failed because of the high altitude and speed of the spy planes. The only damage they inflicted was on October 10, 1957, when a MiG-17 pilot managed to fire a salvo of unguided rockets at a U-2 near Yerevan, Armenia, slightly injuring its pilot. Kármán Vito, the Soviets also developed their high-altitude reconnaissance aircraft, such as the Yakovlev Yak-25 RVB Mandrake, which they used to spy on other countries and to train their pilots to intercept the U-2s. They also shared their intelligence with their allies, such as China and Cuba, who protested against the U-2 overflights. The U-2 did not only fly over the Soviet Union, but also flew over other regions of interest, such as China, Vietnam, Cuba, the Middle East, and Afghanistan, collected valuable information on those areas of political, military, economic, and scientific developments, also supported various operations and crises involving the U.S. and its allies. For example, in 1956, during the Suez Crisis, when Britain, France, and Israel attacked Egypt over control of the Suez Canal, the U-2 provided accurate information on troop movements and airfield conditions to help Eisenhower pressure his allies to withdraw from Egypt. In 1960, during the Second Taiwan Strait crisis, when China threatened to invade Taiwan over disputed islands, the U-2 monitored Chinese air and naval activities to help Eisenhower deter an attack on Taiwan. In 1962, during the Cuban Missile Crisis, when the Soviet Union secretly deployed nuclear missiles in Cuba, sparking a confrontation with the U.S., the U-2 took photographs that confirmed the presence of missiles in Cuba and later verified their removal under a deal between Kennedy and Khrushchev. The U-2 also played a role in easing tensions during these crises by providing reliable information to policymakers and preventing misunderstandings or miscalculations. The U-2 was a remarkable aircraft that changed history by revealing secrets and reducing fears, but it also faced challenges and controversies that threatened its existence. Flying the U-2 was not for the faint-hearted. It was a risky and demanding job for both pilots and ground crews. The U-2 was designed and built for minimum weight, which meant it had little margin for error, was susceptible to crosswinds, turbulence, and stalls, had no landing gear or flaps, and had to land on its belly, had no power-assisted controls, and required much physical strength to operate, had no ejection seat, and the pilot had to wear a spacesuit to survive at high altitudes. The U-2 flew close to the edge of its performance envelope, in a narrow window between its maximum speed and stall speed. This window was called the coffin corner because if the pilot exceeded either limit, he could lose control of the aircraft or cause structural damage. The U-2 also flew very close to the edge of its operational envelope in a hostile environment where it could be detected and attacked by enemy radar, fighters, and missiles. The U-2 pilots had to endure long hours of flying in extreme conditions, with little margin for error or distraction. They had to breathe pure oxygen for an hour before takeoff to prevent decompression sickness. They constantly monitored their instruments, cameras, and radios while avoiding enemy defenses. They had to land the aircraft with the help of a chase car, which told them their altitude and attitude. They had to deal with fatigue, dehydration, hunger, cold, and loneliness. The U-2 ground crews had to work in secrecy and under pressure, often in remote and hostile locations. They had to maintain and repair the aircraft with limited resources and spare parts. They had to prepare and load the cameras and sensors for each mission. They had to refuel and launch the plane with precision and speed. They had to recover and unload the aircraft after each landing. They had to process and analyze the film and data collected by the aircraft. The U-2 operations were not without accidents and fatalities. Since its inception in 1955, more than 50 U-2s have been lost or destroyed in various incidents, killing 35 pilots. Mechanical failures, such as engine flameouts or fuel leaks, caused some incidents. Human errors, such as stalls or navigation mistakes, caused some. Weather conditions, such as icing or thunderstorms, caused some. Enemy actions, such as missile attacks or interceptions, caused some. One of the most tragic accidents occurred on May 15, 1956, when a U-2 pilot named Wilburn S. Rose stalled his aircraft during a post-takeoff maneuver to drop off the wingtip outrigger wheels. He lost control of the plane and crashed near Edwards Air Force Base in California, killing himself and 2 civilians on the ground. Another fatal accident occurred on August 31, 1956, when a U-2 pilot named Howard Carey stalled his aircraft immediately after takeoff from Wiesbaden Air Base in Germany. He ejected from the plane, but his parachute failed to open correctly. He fell to his death near the airfield. A third fatal accident occurred on September 17, 1956, when a U-2 pilot named Robert Seeker disintegrated his aircraft during ascent near Giebelstadt Air Base in Germany. He was flying at an altitude of 72,000 feet when he encountered severe turbulence that exceeded the design limits of the plane. He broke apart in mid-air and died instantly. These accidents raised questions about the safety and reliability of the U-2 program. They also exposed some of the secrets of the program to public scrutiny. The CIA used cover stories or diplomatic maneuvers to conceal or justify its overflights. For example, it claimed that the U-2 was a weather research plane operated by NACA or USAF Air Weather Service. It also claimed that some overflights were accidental intrusions due to navigational errors or equipment malfunctions. However, these cover stories could have been more convincing and consistent. The Soviets knew the U-2 was a spy plane from their radar tracking and visual sightings. They protested vehemently against the violations of their airspace and sovereignty. They also tried to shoot down or capture any U-2 that entered their territory. The most famous incident occurred on May 1, 1960, when a U-2 pilot, Francis Gary Powers, was shot down over the Soviet Union by a surface-to-air missile. Powers flew from Peshawar in Pakistan to Bodo in Norway, overflying some of the most sensitive Soviet targets, such as Sverdlovsk, Chiritam, and Plesetsk. He was flying at an altitude of 70,500 feet when an SA-2 guideline missile near Sverdlovsk hit him. He managed to eject from the plane and parachute to the ground, where Soviet forces captured him. This incident was a major embarrassment and a diplomatic disaster for the US and the CIA. Exposed the U-2 program to the world and damaged the relations between the US and the Soviet Union. Also jeopardized the upcoming summit meeting between Eisenhower and Khrushchev in Paris. The US tried to maintain its cover story that the U-2 was a weather plane that had strayed off course due to oxygen failure. However, this story fell apart when the Soviets produced Powers and parts of his aircraft as evidence of espionage. They also revealed that they had interrogated Powers and obtained his confession and cooperation. Eisenhower was forced to admit that he had authorized the U-2 overflights for national security reasons. He defended his decision as a necessary measure to prevent a surprise attack by the Soviet Union. He also expressed his regret for the incident and willingness to stop the flights if the Soviets agreed to mutual aerial inspection. However, Khrushchev was furious and outraged by the U-2 incident. He denounced Eisenhower as a liar and a warmonger. He demanded an apology and a punishment for those responsible for the flights. He also canceled the summit meeting in Paris and withdrew his invitation for Eisenhower to visit the Soviet Union. The U-2 incident marked a turning point in the Cold War, increased the tension and mistrust between the two superpowers, also ended any hope for a peaceful coexistence or a nuclear disarmament agreement. Also impacted the U-2 program, which faced new challenges and changes in the following years. The U-2 incident of 1960 had a significant impact on the U-2 program, exposed the U-2 to the world and damaged the relations between the US and the Soviet Union. It also led to the suspension of overflights of Soviet territory by President Eisenhower, who did not want to risk another confrontation with the Soviets. However, he did not cancel the U-2 program altogether. He authorized other reconnaissance flights that did not violate Soviet airspace, such as peripheral flights along the borders, satellite photography, and balloon launches. He also supported the development of a successor aircraft that could fly higher and faster than the U-2 and evade Soviet detection and interception. The CIA and Lockheed started working on a follow-on aircraft in 1959 under the code Oxcart. The new aircraft was designed by Kelly Johnson and his team at the Skunk Works, using advanced materials and technologies to achieve stealth, speed, and altitude. The helicopter was called a 12, a sleek, black Delta wing plane that could fly at Mach 3.2 and 90,000 feet, was powered by two Pratt & Whitney J58 turbojets that used a special fuel called JP-7, carried a sophisticated camera system that could take high-resolution pictures from 80 miles away, also had electronic countermeasures and defensive strategies to jam or evade enemy radar and missiles. The A-12 was a highly classified project that faced many technical and operational challenges. It required a new airbase at Groom Lake to accommodate its long runway and large hangars. It also needed a new fleet of tanker aircraft to refuel it in flight. It suffered several accidents and delays during its development and testing. It was costly and complex to maintain and operate. The A-12 first flew in April 1962 but was not ready for operational use until 1967. President Kennedy had approved a modified version of the A-12 for the USAF called SA-71 Blackbird. SA-71 was slightly larger and heavier than the A-12. Still, it had two seats for a pilot and a reconnaissance officer and carried more sensors and equipment. SA-71 also had a more extended range and endurance than the A-12. Su-71 became the primary strategic reconnaissance aircraft for the USAF from 1968 to 1998, flew over many targets worldwide, including Vietnam, China, North Korea, Libya, Iran, Iraq, and Afghanistan, set many records for speed and altitude, such as flying from New York to London in less than 2 hours in 1974. Also survived many attempts to shoot it down by hostile forces. Thanks to its speed, altitude, stealth, and countermeasures, the U-12 was used by the CIA for only 1 year. From 1967 to 1968, flew over Vietnam and North Korea during Operation Black Shield, provided valuable intelligence on enemy activities and movements during the Vietnam War and the Pueblo Crisis. However, it was also very costly and risky to operate. One U-12 was lost over the South China Sea in June 1968 due to mechanical failure, killing its pilot. The CIA terminated its Oxguard program in December 1968, transferring its remaining U-12s to storage or museums. The U-2 continued to fly alongside the U-12, but Su-71 for many years underwent several modifications and improvements to enhance its performance and capabilities. In 1967, it received new engines Pratt & Whitney J75 that increased its maximum altitude to 76,000 feet and its top speed to Mach 0.9. In 1971, it received new radars SARS-I that could map terrain features and detect moving targets from long distances. In 1979, it received new sensors Senior Spear that could collect signal intelligence from various sources. In 1981, it received new cameras SIRES to take multispectral images in visible or infrared wavelengths. In 1994, it received new engines General Electric F118 that reduced noise and fuel consumption and increased reliability and service life. In 1998, it received new radars SARS-2 that improved resolution and coverage and added synthetic aperture radar and ground-moving target indicator modes. In 2002, it received new sensors Senior Year Electro-Optical Reconnaissance System or SIRES-2 that could take high-resolution images day or night. In 2012, it received new cockpit altitude reduction effort or care that increased cabin pressure and reduced the risk of decompression sickness for the pilots. In 2015, it received new communication systems Communications Gateway Payload or CGP that allowed it to relay data from other platforms to ground stations or command centers. The U-2 also faced competition from other reconnaissance platforms, such as satellites, drones, and stealth aircraft. Some of these platforms were developed to replace or complement the U-2. The Corona satellites began taking photographs of the Soviet Union and other targets from orbit in 1960. They had the advantage of being immune to interception and protest. Still, they also had limitations such as low resolution, short lifespan, weather dependence, and slow recovery. The RQ-4 Global Hawk is a large, uncrewed aerial vehicle that can fly at 60,000 feet and 350 miles per hour for over 30 hours, can carry various sensors and cameras and transmit real-time data via satellite links, has the advantage of being cheaper, safer, and more persistent than the U-2. Still, it has drawbacks such as lower altitude, higher radar signature, and less flexibility. The MQ-4C Triton is a naval version of the Global Hawk that can perform maritime surveillance and reconnaissance missions, can fly at 56,000 feet and 357 miles per hour for over 24 hours, can carry a multifunction active sensor radar, an electro-optical infrared camera, an electronic support measures system, and an automatic identification system. It can provide a 360-degree view of a large area of interest and share data with other platforms and stations. Lockheed Martin's Skunk Works are developing the RQX, a proposed successor to the U-2, is expected to be a stealthy, uncrewed aircraft that can fly at 70,000 feet and Mach 0.9 for over 20 hours. It will use the same engine and cockpit as the U-2 but will have a larger airframe with more power and cooling for new sensors and systems. It will also have an optional manning capability and low observability features. It could be ready for service by 2025. Despite its age and limitations, the U-2 remains in service and relevant for modern missions, still provides unique capabilities that other platforms cannot match. The U-2 can fly above most weather phenomena and air defenses, giving it a clear view of the ground and a wide coverage area, can also avoid detection by some radars and infrared sensors optimized for lower altitudes. The U-2 can fly faster than most drones and satellites, giving it more agility and responsiveness, can reach its target area quicker and stay on station longer than most human-crewed aircraft. the U-2 can take very detailed images and signals from its sensors and cameras, giving it more accuracy and reliability. It can also adjust its sensors and cameras according to the mission requirements and environmental conditions. The U-2 can carry various payloads depending on the mission needs, can also change its flight plan and altitude according to the situation, can also communicate with other platforms and stations using multiple modes and frequencies. The U-2 can evade or counter most threats using its altitude, speed, stealth, countermeasures, and tactics. Can also benefit from the presence of a human pilot who can make decisions and judgments in complex scenarios. The U-2 has been involved in many operations and conflicts since its inception, has supported NATO operations in Europe, Asia, Africa, and the Middle East, has monitored natural disasters such as earthquakes, volcanoes, floods, fires, hurricanes, tsunamis, oil spills, etc., has conducted scientific research on climate change, ozone depletion, solar activity, etc., has tested new technologies such as sensors, lasers, data links, etc., the amazing spy plane that flew higher than any other aircraft in the world. The U-2 is a remarkable aircraft that changed history by providing valuable intelligence and information to policymakers and decision-makers, is also a testament to human ingenuity, courage, and curiosity. It is a tool that helped shape history and reveal secrets, is a legend that continues to fly and inspire. We hope you enjoyed this video and learned something new about this amazing aircraft. If you did, please give us a thumbs up and share this video with your friends. If you have any questions or comments, please leave them below. We would love to hear from you. If you want to see more videos like this, please subscribe to our channel and hit the bell icon to get notified when we upload new videos. We have many more amazing aircraft to show you, so stay tuned for more. I appreciate your support and see you next time on Amazing Aircraft.